Hey, buddy. How are you doing?
Fine, and you? How are you?
Yeah, not bad. Not bad. The sky's blue today, which makes a nice change, doesn't it?
Are you in Newcastle still?
I'm sat on the riverbank as we speak.
Nice. Okay.
I think you're just over the other side of the river, aren't you?
Yep, that's right. You're in Newburn.
So, hey, yeah. So you're now at Rak.
Yep.
New role.
New role, yes. Joined this month. So from Reese Innovation, where I was before, doing solar pods. And now it's a big company, lots of interesting products, and I'm here to talk about one of them, actually.
Awesome. So my three questions, as always. Mm-hmm. How old were you when you first used a soldering iron?
Oh, I was about 6 years old, I think. It was my grandfather who taught me how to use it. I got burned a lot back then, and I still do, actually. So, yeah.
Well, funny enough, that was one of my sub questions to that one was, how old were you when you burnt yourself for the first time with a solder?
Oh, it was pretty much 6 years as well. Like, when I started. So easy, isn't it?
It is, and I still do it today, which is why I try not get it out too much. What's the favorite project that you've worked on? You know, you and I have known each other for a few years now. You've been a great member of IoT North, and you know you've been involved in some really cool projects. What's the favorite one that you've worked on?
I think it was a Legionella monitoring project I did, which was all across the UK. So I had to travel a lot and install sensors and gateways and all sorts of things. So it was kind of the full stack, from creating the device to writing firmware to getting device done, actually here in Newcastle as well, which was quite cool. And then it's now on the high street, it still works. The company in the meantime has done a lot more devices. Yeah. So it's a good project, and I'm very happy to have participated on it.
What year was that project, out of interest?
That started probably 2 years ago, I think.
Yeah.
So
right. Yeah. Was that part of the water, with Northumbrian Water and all?
No. It's a separate company who's doing this.
And you know, I know you're a huge advocate of LoRa, and I saw your comments on Sigfox today on LinkedIn. How's LoRa evolving? Are you seeing more new uses? Do you think it's really going to build strength on it? Yeah,
I think the networks are converging now into basically two technologies probably, and LoRa is definitely one of them. It's a very open technology, long range, low power, and anyone can set up a network. So it's really it's very accessible to anyone, and companies are seeing this. So we are at Rak. I'm now seeing quite a lot of interest on LoRa. It is Rak's main product, and it's growing in retail, farming, everywhere really. Security as well. So I'll talk about some of that.
I think that leads on quite nicely for you to take over.
It does,
and give us your talk.
I'll just share the screen. Okay, let's see. Can you see this? Yep. Okay. Hello, everyone. Sorry, can you see the screen?
We've got a black screen at the moment.
Oh, God. Okay.
I can see
That's
it.
Not good. Okay, maybe if I move this here. No?
There we go.
Nope.
Yeah, we've got you.
Okay. Thank you very much, Paul, for inviting me again. And this time I'm quite excited by this product. It's a new product from Rak. It's not been officially announced yet. It's going to be announced next month. But so let's just move on to. There's some. Okay. So what is Rak? Rak is quite a new company. So it's about 6 years old. It started in Shenzhen, China. It's also now has offices in Xi'an, Bulgaria, and now I'm leading the Rak team here in Newcastle, which will be a team quite soon as well. So the main product area of Rak has been on LoRaWAN. As Paul mentioned, LoRaWAN is a nice radio system where you have a very low power radio combined with a network anyone can deploy using gateways. So one area where Rak has been really strong has been on the gateway side. So they have several gateway products and they're very popular, mostly around the Raspberry Pi products. So you can turn any Raspberry Pi into a LoRa gateway, which is really interesting. But we also have professional gateways, which are being deployed now everywhere. That was actually the gateway I used at the previous product called the SolarPod. And now we're working on several software products as well on the network server side. So Rak works with a stack called Chirp Stack, which the stack is just how the LoRa protocol is implemented on the networks end. A relatively new area for Rak has been on the node side. So they started with some modules for LoRa. So this is what you can usually use in the LoRa devices. And they've also worked on NB-IoT devices. We are also adding Sigfox to the mix very soon. So this is an upcoming product. So today I'm going to talk mostly about the node side, because this is where I find really exciting. The gateways we have it pretty well covered with the product range we already have, but the nodes is where we can really help. So I'm just giving like an insight how a typical IoT project starts, where you want to develop some sensors. So you usually get some development board. That's just one example there on the slide. Or there's lots of development boards already on the market. You just get one of those. You wire things up, connect a few sensors and some extra boards, and it becomes like an early stage proof of concept. So you can show this to a client. Sometimes you can, with the sensors, like sending data over LoRa to the backend. Client is happy, or he suggests some modifications, but it's a start. Then once that phase is done and the client is happy, you tend to go into a prototype stage. So this is where you actually create a PCB for the device. You usually get some modules just to make things easier on the radio side, because radio modules tend to be difficult to design. So you leave that part to the experts. You get a ready-made module, you just put that on the board, and you can basically just do the same you did on the original proof of concept. But this is a more scalable product, so you can do 100 units, for example. That's a typical prototype size. This is something now you can finally send to a client for test. So it's not it doesn't scare people away like with full of wires. It doesn't come off that easily. So it's on the way to being a ready product. So once you do that, you do your tests, and usually I think a typical time frame is 9 months from the prototype stage. So once you do all your tests, you finally have an idea what the device should do or what it shouldn't do. You do your PCB design modifications, or someone does that for you as well. That's the most typical, is where a startup uses external contractors for that. And once you're happy with that, 9 months later, you're ready to go into production. So this is what production looks like. It's just robots making your boards for you. So this is how usually hardware is being done at the moment. You start with requirements. So it's a kind of a waterfall module. So once your device is ready at that final stage, you don't go back usually, because that'll mean you have to respin your board. You have to make a new device, and that changes everything. So certification, everything you've done so far, it just gets thrown away almost. The only thing you can use are basically the original PCB designs. So it's very, very difficult to modify a device once it's in the field. And this is quite a big problem, because sometimes you just find problems at a very late stage in the project. So imagine a project where you are doing a weather station. Everything looks good up to the end. And then at the end, they find out that they actually can't get NB-IoT coverage, for example, or Sigfox coverage, and they suddenly see, oh, okay, we've got to go to LoRa. And then that means changing the whole board, everything has to go back, and it's a big problem. Also, sometimes you also have a lot of devices deployed already, and for some reason nowadays, security is a big thing. And imagine someone finds a bug in one of the microcontrollers, which is very possible, just happened recently with Nordic. So then the only solution is to replace the hardware, but that means like replacing all the boards. It's a very expensive error to make. So really, this is this needs to change. This needs to be more agile, so you can swap things on the board even once you already designed it. That's something that's, I think it's really important for IoT. So some solutions out there, like this is called the SparkFun Quick. It's just based on wires. So you've got some boards with all the sensors, and then you have basically a serial wire connecting everything together. And this works well, but it's still a messy device. So it's not something you want to send to a client. I mean, the connectors can pop off, and then suddenly the device doesn't work. The client doesn't know what is going on. And he opens the device and he sees like a bunch of wires. It looks like a bomb. It's not something that is ready. And also it costs a lot of money. It's not, this is not production ready hardware, that's for sure. So it's good for the proof of concept stage, but not good for the final production. So faced with these problems, I mean, Rak has been thinking with it for a long time around this. So we came up with this solution, which I find really good. It's we basically put all the modules we have and all the sensors on separate small boards. Just very tiny. I'll show you the scale shortly. And they all fit onto a baseboard, a common baseboard. And you can change any component on this. It's all open source hardware. So you can change the baseboard if you want more features on the baseboard, but you still use the modules. And we use a common set of connectors for this. These are high density connectors from the mobile phone industry. So they're very cost efficient. They don't add a lot of cost to the final product. The extra PCB itself doesn't add a lot of cost to the product. So it's really a nice way to take the device from proof of concept stage up to even production. So even if you have to do 1,000 devices using this system, it doesn't cost a lot more just because of all the modularity. But you get that safety of knowing that you can change things at any stage in the project, even after deployment. Also, that means you don't need to solder anything, which is great for people who get burned like me or a lot of people. I mean, it's not soldering. Some people enjoy it. Some people find it relaxing. But if you have to do it for 100 devices, it's not fun, I guarantee you. So what we have now, Rak has already a lot of modules made for this system. So most of the modules are for LoRa. These are just the description of what the modules are. We have 3 microcontroller families. We have the Nordic semiconductor, which includes Bluetooth. We have ST Micro, which is an ARM Cortex M4 or M0. And we have the Atmel some R34, which is another ARM microcontroller, which has a built-in radio. So it just depends on what kind of development platform you prefer. Some people prefer the Atmel devices. Some people prefer ST and others prefer Nordic. So we just offer everything. You can choose which one you want to use for your product. So most of these are already available. Just the ones in orange are not available yet, but they will be coming. For sensors, we already have a lot of sensors around temperature and humidity sensors, environmental sensors, accelerometers, gyroscopes. So that's all already on modules you can buy right now. And then you just connect it to the board. We also have GPS now available. So this is great for tracking applications, which are super popular now. And then we add an extra layer, which is what we call the I/O module. So this is slightly larger modules which connect to real things in the world, like a Modbus, which is typical for industrial applications where you want to sense machinery, 420 milliamp bus as well. Or even to NB-IoT, so we have a cellular I/O module. So you can start with a LoRa device, and if later you find out that actually I need cellular for this particular application, you can just get the cellular block, you connect it like a Lego block, and you develop your code for it, of course. But the hardware is just like Lego, really simple. I'll show you shortly. So this is what the board looks like. On top of the hardware side, we support a lot of development platforms. So we already have Arduino support. We're adding now MicroPython. And we are all working on the Espruino side. This is the JavaScript for microcontrollers. And of course, we'll also support CircuitPython, which is super popular with Adafruit for the educational market. I think most people currently, they will prefer the Arduino, so we get programming the board using C language. This is typical for embedded development, but MicroPython is getting quite popular now, so we definitely support that. Even on the LoRa side, so you can use MicroPython for LoRa. So this is one example project I worked on recently. This is a weather station we developed for a UK university. So what we did was we took the rack enclosure. This is that box on the left side. That's an IP67 enclosure. It already works with WizBlock, so you've got the full stack, so not just the board, but also the enclosures, the batteries, everything has been tested for this system. We added the one cable module, so this is something that just gets one cable out. Then we added the battery. Then the final product on the right is what it looks like mounted on a pole. Actually, the Reese mechanical team designed that bracket system. That's basically what they designed, but you can put it anywhere, really. This is what the full module looks like in more detail. I'll show you on the camera shortly. So on the left here, you've got the LoRa and Bluetooth module, and you've got also populated the cellular module. So this is just an add-on on that, using that WizIO system I mentioned. So you can snap this off, the cellular part, if you don't need it, or you can add it in. And the really nice thing is, once you've got this board and you've got the sensors you want put in, you can just tell Rak, come do me 100 of this or 500 of this. And Rak knows exactly what you need. It knows the enclosure you need. You can decide which holes you want on the enclosure or not. So that's something you can tell Rak, and they'll get your device produced even in mass quantity at a very efficient costs, really efficient cost. So I've got a little video for you, I think. Hope that wasn't too loud. Okay. So I'll stop sharing now. And let me change my camera. Okay. hopefully you can, ooh, the resolution is a bit off. So can you still hear me or?
Yep, all loud and clear.
Yep. Okay, great. So I'm just demoing. This is one of the boards. It's got, this is the SUM-R34 module on there. So really all I need to do to change it is take those screws out there. So there's 4 screws. I usually do this on camera, but I'll get a bit, they are fiddly, a bit fiddly screws. Let's see if I can do that. So it just comes off. And you just remove the 4. I won't do it now, it's just not to bore you. But once you have that, basically you get a CPU module like this. So you've got the microcontroller and the port for the antenna there. Oops, sorry. Small accident. On the back side, you can see the connectors we have. And on the CPU module, like you say, we have very, very tiny connectors. So for scale, this is a typical business card. And the whole board, it's much smaller than that. So I'll move that there. And if you want to add other modules, we'll lose the image now.
Yeah, we should.
Oh, there we go. Sorry, I had to change my camera. So this is the Modbus module. So imagine you want Modbus on your device. So you start with the baseboard. You just basically connect the 2. You gotta line them up there. Then you click, and then you can put a screw there. So the screws just help secure it. So even if you have vibration environments, it stays in place. It doesn't come off. We have standoffs there, which just go there on the mount on the screws. So on this board, I also have this here is a light sensor. So that's one of the small sensor modules, which are really, really tiny. So again, we have a connector on the back. Just connect them and they become available. The sensors we support are SPI and I2C. So this is, and also UART sensors. This is all the typical industry standard for sensors. So you can use anything almost you want. We're coming out with an exciting module, which is Pda Microphones. So you can use that for audio, so edge processing on audio. This is something that is supported by the Nordic microcontroller, which is quite powerful. It's a Cortex M4. So we are working now with companies like Edge Impulse, who do edge processing on microcontrollers, and to analyze that audio and actually apply machine learning models to it to detect certain features in the audio, or the accelerometer as well. So it's a very exciting space at the moment around that. And on the new module, I'm very pleased to announce that we also will support Lacuna Space. So this is the satellite system using LoRa. So basically you can take this device and instead of sending it to land gateways, you just send it to space, to the lower orbit satellites they have. You don't need to change anything. It's just a change in the software. And the antenna, of course, it's a bit different. But that is the WizIO system. As I said, it will be released early next month. We're still planning on some good launch party. So if you know any spaces, let me know. But this, I think this will change how IoT is developed, because it just makes things, you can make mistakes and you can change them later on. It doesn't kill the project anymore like it used to. And you can always upgrade the devices in the field. So even if you have all the devices, got all the sensors you've got, and you just want to add connectivity, you can add the cellular module. I think this is quite a good feature. I'll change my video back. Okay. Hope you like that. If you have any questions, let me know.
That's brilliant, Jose. We've got a couple of questions. So, Mr. Steve Camish, what is the major usage for this? Is it remote monitoring like we know on poles in smart cities, or any other domains growing for you?
So we have, like I said, there was a client already using this for the weather sensing, so environmental sensing, both indoors and outdoors. So there's 2 projects around this already. We are looking at a very big application in tracking. So this is, some companies have been looking at tracking things around the world, asset tracking, and they have found that cellular sometimes isn't enough, or sometimes they need 2 cellular modules, for example, which is just crazy, really. So you need 2 SIM cards on the device just to make sure that you got the world covered. So actually what companies come to us and say, oh, maybe we just use LoRa and some cellular. So when the device is outside, we can use cellular, but when it's inside our shops or our infrastructure, they can track it there using LoRa. So a device which has both is definitely interesting. And it's, so I think it will be mostly in those areas. There's, I mean, but you can do anything with this. It's like a generic sensor, really.
What's the price point? So actually, Stuart's asked a good question, which sort of leads on to the one I was about to ask. Is Stuart's interested to know if it will just be available as parts, or are you offering bundled kits for projects?
We are offering bundle kits, yeah, but also the parts. You can decide what you want.
What kind of price are they?
So most of the modules, so the LoRa modules, be under around $20, something like that. With the board, that comes to about $30 for the board and the module. A basic setup, basically.
Yeah.
If you add cellular, of course, that's a bit more. And if you want to pack it with sensors, so this board can take up to 4 sensor slots. Yeah. So you want to pack it, you can probably get to $70 or something like that.
Yeah, and so correct me if I'm wrong. In here, it's very much a modular hardware setup that, as you mentioned, there's coding to be done to get things working. Is there any recommended, or have you found any modular software that accelerates that development?
We've not, and that's the part that's missing, isn't it? It's like we need something that is low code, some kind of infrastructure which allows that. That's not available yet, no. But I guess MicroPython makes it easier, but we're not completely there yet. We need partners that will want to take that on and adopt that, adopt our board.
Yeah, interesting. Okay, so Nanlin has asked, what kinds of machine learning methods are embedded in the device? Have you tried data stream mining to detect changes of data patterns in runtime?
No, I've not. Like I mentioned, that the machine learning part will be done by our partner, Edge Impulse, which is a new company around machine learning on microcontrollers. So I don't exactly know what they can offer yet, but we'll know soon, I guess.
Okay, excellent. Does anybody else have any questions? So this is from Matthew Roberts. Do you have a link for any further information on Wiz.io?
We're just finalizing the webpage, so this hasn't been released yet, but I can share information if you want. Feel free to contact me I can share my email on chat. I guess that's the best option.
Yeah, and any information that you'd like me to share with the meetup group as well, I can share it out with one of the newsletters and posts that I do.
That's great. Yeah, I'll do that then. I'll share some slides.
Yeah, if you want to share your email address in the chat, by all means,
I will. Okay.
Okay. Jose, as always, really good to see you in a really exciting new role.
Thank you.
And looking as excited as you always do, playing with boards. Great to catch up.
No soldering. Yeah. Thank you very much. Thanks.
No more burned fingers.
No.